Let's take a look at another question. Here we have a question that reads, how much sodium chloride must be added to the prescription to make the solution isotonic? So here we're looking at isotonicity. We have a formulation that's provided us. We do see what is known as the E value right here. And we know the total quantity of this eye drop. So our goal is to figure out how much of the sodium chloride we need to make the solution isotonic. Okay. The first thing we want to do is identify what kind of a problem this is, because there's a number of ways you could adjust tonicity. You could use freezing point depression. There's no freezing point given us, so it's definitely not that approach. And the most likely one is the sodium chloride equivalent method. So that's what we're going to use. And you could do that in what I will describe as 3 very nice straightforward steps. I do have a video on the sodium chloride equivalent method. You can check it for details. So first, the first step, let's just call that step 1. What we need to figure out is we need to determine actually the quantity that we need of sodium chloride by itself to make this volume isotonic. Okay. And the way we do that is to make use of the fact that an isotonic solution is basically 0.9%, so 0.9 grams in 100 ml. That concentration is what makes a solution isotonic if you're just using sodium chloride. Now, since we have a 30 ml volume, we need to adjust the quantity accordingly. So if we solve for our unknown, which is x, it's going to be 0.9 grams times 30 ml over 100, and that should give you 0. So that's 27.27 grams. So if we had nothing in there but just the sodium chloride, we would need 0.27 grams to make it isotonic, to make 30 ml isotonic. However, we do have tetrakane hydrochloride, and that's going to contribute some tonicity because it has some particles in there. All right, so we also need to determine how much, or the contribution of the tetrakane hydrochloride. So let's just call this, so determine the contribution from tetrakane HCl. Okay, and the way we do that is to utilize the concentration given us. So there's a concentration. We'll try and convert this to mass. So we need to find out what is going to be for this volume. This is a percentage strength, and then we'll multiply that by the E value. The E value is kind of like a conversion factor. You know how if you want to change from like dollars to euros, you need an exchange value. The E value is kind of like the exchange value that helps you move between quantities in, let's say, grams to its equivalent in sodium chloride quantities. Okay, so the way we will set that up is 0.5%, that's 0.5 grams in 100 ml, and we have a 30 ml. So we're now in grams, and if we multiply that by the E value for tetrakane hydrochloride, that will end up giving us 0.027 grams. Now what this means is the tetrakane hydrochloride in this preparation is contributing an equivalent of tonicity of what sodium chloride to 27 milligrams would. Okay, so if we wanted to figure out how much sodium chloride would give the same amount of tonicity as 0.5% tetrakane hydrochloride, that number will be 0.027 grams or 27 milligrams. Okay, So that brings us to the very last step, which is, I will say, step 3, and that will be to figure out the quantity of sodium chloride that is actually needed to make the solution isotonic. Okay. And so that's basically going to be a simple subtraction. So we're going to subtract step 2 from the results from step 2 from step 1. Okay. So here we have 0.27 grams from step 1, and we're going to subtract the 0.027 grams from step 2. And that's going to give us, based on the calculator, 0.243 grams. Okay. So that's how much more NaCl we need to add to this preparation to make it isotonic. Okay. So key thing is, you first figure out if you have nothing but NaCl in that volume, what's it going to be to make the solution isotonic. And then you figure out the contributions from the components in there. Now, if we had additional ingredients, let's say you have something else in addition to the tetracane hydrochloride, you need to find for tetracane and also find for the additional component and subtract both those quantities from your answer in step 1. Okay. Now, if you do that correctly, that gives you 0.243 grams for this question, and that will be the solution for this problem. Okay.